physics. Okay, so we have the primitive laws of physics. Okay, the primitive laws of physics, which are basically very legendary laws of physics, because those are very popular to all of you, all of us, and very legendary equations in physics, and those are very popular also in your schooling, in your graduation, and also in your master degree also. Those laws are very essential for studying the physics. So the important laws of physics, those are basically, first of all, Newton's laws of gravitation. Newton's laws of gravitation, which says the force between two masses is equal to G m1 m2 by r square. Second one is Coulomb's law, right? Second one is Coulomb's law, which says F equals to 1 by 4 pi epsilon naught, the interaction of two static charges, which is q1 q2 by r square. And the third one, which is Biot-Savart law, which says df is equal to mu naught by 4 pi I dl cross r by r cube. You have any current element of dl and you are going to find the, sorry, I have made some mistake. This will be dB. Okay. So the magnetic field at a point r from the current element dl is basically this Biot-Savart. So these are the primitive laws of physics, you can say, and those are very important also for studying the basics of physics in your schooling, in your graduations, and of course in your master degree. Everywhere these laws of physics are very essential. But these laws of physics suffer from two important issues. Okay. There are two important flaws. Okay, two important flaws of these primitive laws of physics. The first one is these laws are very global. Okay, first of all, these laws are very global, and second, these laws are instantaneous. The important flaws. First of all, first flaw is these laws are global laws of physics, and second is these laws are instantaneous laws of physics.
सर ग्लोबल बोलते हैं?
हाँ बोलছি okay. So firstly, what the first flaws is that these laws are global. What do you mean by global? Suppose you have a electron here. As per the Coulomb's law, it will make effect another electron which is at infinity. Suppose you have another charge is at America, but as per the Coulomb law, there will be some force between them. The force will be 1 by 4 pi epsilon naught e square by r square. R is not infinity. Maybe it is at America, but the distance is finite. So that's why theoretically they have some mutual interaction between them. So the Coulomb's law, the Newton's laws of gravitation, the Biot-Savart law, the main flaw of these laws are they are very global laws of physics because the theoretical range of these forces are infinite. Because the theoretical range of this interaction is infinite. That means if you have a source here, it's a source S1 here, and you have another same type of source at any finite point which is very long from here, but theoretically they have some interaction. So that's why I'm saying these laws are very global laws of physics. Okay. So the effect of S1 is extended even up to the infinity. That means the theoretical range of this interaction is infinity. Okay. But actually, but practically, these interactions which are described by this familiar laws of physics. So these interactions are not global, they are local. They are very local interaction. Why they are local? Because practically, suppose you choose some electron has the practical range in the atomic level, in the atomic range, atomic radius. Okay, so practically these interactions are not these interactions have not the infinite range. Practically these interactions have some finite range, and thus they are very local. They are very local interaction or local laws of physics. So that's the first problem with these primitive laws of physics, because these laws describes the interaction which are global, that means which have the infinite range, but practically they are not global because they have the finite range. So this is one difference in the practical and the theoretical description of these interactions. The first. Second flaw is the instantaneous. Why instantaneous? Because actually these laws, that means Coulomb's law, Newton's laws of gravitation, Biot-Savart law, this states the interaction between static charges. Suppose you have a q1 and q2, you have F equals to 1 by 4 pi epsilon naught in free space, q1 q2 by r square, if they have r distance apart. So whenever when they are at rest, this is no issue with these laws. But suppose one charges or one sources, it starts moving like that, then the interaction will be instantaneously changed. Suppose it will go from r to r prime, the force will be changed up to 1 by 4 pi epsilon naught q1 q2 by r prime square. So whenever the charge is at r distance apart, it will be 1 by r square, and whenever it is at r prime, it will be 1 by r prime square. And the change is found instantly. There is no time interval required to change this force or change this amount of interaction at q1, because as per Coulomb law, they will change automatically and instantaneously. But this means the interaction signal, requires no time interval. That is, it flows with infinite speed. The interaction signal flows without any time interval. That means what will be the speed? Speed means distance by time. So there will be some finite distance by 0, which is speed is infinite. Okay? But practically, nothing can be faster than light. So as per STR says nothing can be faster than light. So the speed of light is c. So literally these laws of physics violates the ideas of STR. All of these, Coulomb's law, Biot-Savart law, all these are violating the STR because they are instantaneous laws of physics. But actually STR is possibly the only one theory in physics which is flawless. So only one theory in physics which is flawless. So that means if it violates STR, so that means these interactions or laws of interaction has some serious issue. So STR must be followed by any valid laws of physics. So these are two basic flaws of our known laws of physics, our known primitive form of the laws of physics. So we have to modify this one. And in order to modify this one, firstly, if you want to resolve the first flaw, you have to introduce the idea of field. So introduction of field. Introduction of field to resolve the first flaw. First flaw, basically. First flaw. So at first you have to know what is field. What do you mean by field? Anyone? What do you mean by field? Hmm? Hmm. Hmm. Achha. Achha, okay. I have to modify this idea actually. What is field? At first, try to remember the uh, early days of your graduation. Basically, when you are seriously introduced with physics, your early early days of your physics or in college. So there you have learned about the scalar field, mathematical scalar field. Phi. Phi was function of x, y, z, or you can say phi of function of r. Okay. So what is scalar field basically? Mathematically, a scalar field is you can say it's a generator of scalar. Generator of scalars. Because it's the function of space, x, y, z. So if you have different values of phi at different points, that means you will find different scalars and at different points of a space. So that's basically the generator of scalar. So it's a scalar field. And also you have find the vector field. Vector field, suppose a function of x, y, z. You have written this one as ax, x, y, z I cap, ay, x, y, z j cap plus az, x, y, z k cap, where x, y, az are the scalar field. So what is a vector field? Vector field is the generator of vectors because at different points in space x, y, z, you will find different vectors. So this is the generator of vector. Okay, the scalar field yields different scalars at the different points in space, and vector field yields the different vectors at the different point. So those are the mathematical scalar and vectors field. So in general, what is field? Field is a quantity where you will find some particular forms or particular values at different points in space. Okay, just like a suppose this is phi. Suppose phi x, y, z is equal to, for example, x square plus y square plus z cube. So that you can put the value of x, y, z and you will find phi. Suppose phi 0, 0, 0. At 0, 0, 0 point, the value of the field is 0. At 1, 1, 1 point, you will find 3. So there may be different values of phi at different points, and they are all scalars. For vector field also, you will find different vector at different points. Now come to the physics. What is from physical point of view? How can you how can you utilize this idea of vector field and scalar field in the laws of physics? Suppose you have some charge q here. This is a source charge. Now it has a particular finite range R. That means R will effect within some sphere of radius capital R. Within that sphere, it will effect appreciably, and after and beyond this sphere, there will be literally no effect of this charge Q. Okay, so that means it has a finite practical range capital R. Now, if you put or if you bring some another source or another charge, basically capital Q, which is test charge. This is test charge. This is source charge. Source charge. So if you put some test charge at any point within the range, you will find the existence of Q. That means they will interact with each other. Okay. So unless you put this Q here, you will not find the existence of this Q. But that does not essentially mean in the absence of Q, it does not have any effect. তাই তো মানে কিউ সোর্সটা কিউ যদি না আনি তাহলে এর এক্সিস্টেন্স আমি বুঝতে পারছি না। তার মানে কিন্তু এটা নয় যে কিউ না থাকা মানে এটা থাকবে না, কিউকে না আনলে এর কোনো প্রভাব নেই। Actually, the effect of Q will be everywhere at every time. But in order to realize the existence of Q, you will have to find some, you have to bring some test charge Q. That means you can explain these things in a very particular or ordered way or any very diplomatic way. This Q creates some effect at every point in the range of its charge, range of this charge, and any other test charge will find this effect if it is bring into the range or bring within the range. Okay, and you know from Coulomb's law, this field is called Q by 4 pi epsilon naught R square. Okay, so this is basically vector field because it depends on the direction, it yields some direction, so it's a vector field. And also you may find some quantity called the vector potential, electric potential Q by 4 pi epsilon naught R. So this is basically the scalar field. So any source charge can produce a scalar field, namely the potential, and also it can produce some vector field, namely the electric field intensity. And if you put some another charge there, you will find the existence of this Q. But that does not mean it has no field. It has already a particular electric field and the potentials. But in order to find its existence, you must bring another source or another charge within that range. Okay. So the role of the field, what is the role of the field? The role of the field is to describe the effect of this charge within the space-time, at the space-time points within the range. Okay. So every source, where there is a source, there is a corresponding field within the range of this, and another same type of source will interact by its field, so that you can make the interaction. So that is called namely the field. And by introducing this field, you can resolve the first issue or first flaws of the laws of physics you have found. Suppose for Coulomb's law. For Coulomb's law, you have a source charge Q, and the range, the theoretical range is capital R. Now, at any particular point R, the electric field E will be, suppose you put some capital Q here, so the force will be so the force you can write for it is F is equal to 1 by 4 pi epsilon naught Q into phi R square, where phi of R is equal to 1 by R for r less or equal to capital R, and equals to 0 for r greater than r. So instead of taking the direct effect of the position or coordinate, you can put the effect of field. Here phi is the field. So here f is equal to q phi square. Whenever r greater than capital R, that will beyond the range, the field is 0, and within the range you have a field which is suppose 1 by r. Then you can find the original Coulomb's law, but now this Coulomb law is localized, because this represents a particular form of modified form of Coulomb law where there is no effect of the source beyond the practical range. Beyond the practical range, the force is 0. So in order to make the localized laws of physics, we have to introduce such ideas of field. So what is the relevance of field? The relevance of field is to make the laws of physics local. Originally they are global laws of physics, but you can make them local by introducing such fields. Okay, বোঝা গেছে তো? বাকিরা, বাকিদের খবর কি?
মোটামুটি স্যার।
মোটামুটি বোঝা যাচ্ছে, পুরোপুরি নয়।
একটু টাইম লাগবে স্যার, একটু পড়তে হবে, নাহলে
না এগুলো তো এটা জেনারেল জিনিস, এটা তো জাস্ট আমি ডিসকাস করছি। ইটস নট দ্য সিরিয়াস ইস্যু ইন ফিজিক্স, জাস্ট ডিসকাশন how the field are relevant actually. Okay, so in general you have the global laws of physics where force is extended up to infinity, but whenever you replace phi in that form, you will find a localized form of the Coulomb's law. Okay, so the first issue will be resolved in that way. First issue can be resolved the first way, in that way. The second issue is how can you incorporate the ideas of STR? STR should be included. So as per STR, you know, in STR space and time are taken in the equal footing, and this is called the space time, called x mu. And x mu is the space time 4 coordinate, which is basically the 4 vector, which is a time 0 coordinate, that means the time coordinate xt and r. And if you use space time as the coordinate, that means instead of the only space, if you use the space time, it will automatically make the law following the STR. Because if you introduce the space time dependence on the variables, it will make the system non-instantaneous. Okay, because it will say that the system signal, the interaction signal will be propagating with the speed of light. It will not exceed the speed of light. So instead of phi xyz or phi r, you have to use phi of x mu. Then that will automatically allow to incorporate the ideas of STR within the fields. So in that way, you can resolve the second issue also. In the first issue can be resolved by introducing field, but those field are only the function of space. That means the laws of physics will be local. It is okay, but the laws of physics will still be instantaneous. That means it will violate the STR. But if you allow the field to be dependent on time as well as space, that means phi will be the function of x mu, space time 4 coordinate. In that way, you can allow the system or allow the field to be non-instantaneous. That means the interaction signal will follow or will flow with the speed of light. So in that way, you can resolve both these issues. So now we have the more modified form. You have to replace phi, and not only phi, that phi should be dependent on x mu. So this is called the whenever you introduce the phi x mu within the laws of physics, it is the classical field theory. Okay. So in the light of this classical field theory, you have to modify all the laws of physics you have learned till now. এতদিন অবধি তোমরা যা যা laws of physics শিখেছো, basically we are demanding the dynamics. You have to modify all the laws of physics, basically the Euler-Lagrangian equation you have learned shortly. You have to modify all of these things under these new ideas. Okay, so you have to use this idea of classical field theory in order to modify all the known laws of physics, and this is the basics of classical field theory. So today's class is mainly based on the introduction of classical fields, or mainly fields within the laws of physics. And in the second part of this class, there we shall discuss about how can we insert these ideas into the laws of physics, and we can apply this on the various systems. Okay, তো আজকে এই অবধি থাক। তো তোমরা এগুলো একটু স্টাডি করবে। নেক্সট ক্লাসে আমরা একটু ইন্টেন্স ওয়েতে পড়াশোনা করতে হবে এই জিনিসগুলো। তার জন্য টেনসর শিখতে হবে, দ্য বেসিক আইডিয়া অফ টেনসরস। তো সেটা একটু আগে থেকে পড়াশোনা করে রেখে এলে ভালো হয়, বুঝতে সুবিধা হবে। ঠিক আছে, তো আজকে এই অবধি থাক। আর কোশ্চেন তোমাদের থাকলে এখনই করতে পারো, আর না হলে অন্তত পক্ষে একটু